Hi everyone. In this video, we are going to continue our series on end-to-end regression project. This is the sixth part of our project, and in this part, we are going to talk about how you can build a model, do cross-validation, and perform hyperparameter tuning on the data. How you can save and load the data. Let's start. As you can see, we have imported some package and then we will import our data. After importing our data, what we will do, we will simply show the data and convert this data into x and y. After that, we simply do train and test split, right? Let's run this data, right? After running, you can see you have the result. First select watch price as our virtual environment and then run our data, right? And here also you can see the data, and what we have done, we have converted into an x and y and selected discounted price as our predicted value. So discount price is in a negative value, right? And then we have done this train and test split, right? Then import sklearn uh, the linear model, and this from the linear model we need to import uh, the linear regression algorithm, right? And this algorithm we are going to use the predict, right? So first we need to make an instance of this linear regression. We can name it anything. So let's name it. So let's name it like linear regression and then hyphen model, right? And then we will make an object of this linear regression class. After building an object, what we can do, we can simply call this object like a linear um, model object, right? And from this linear model, what we will do, we will fit the data. So simply fitting, we will pass x train and then y test, y train, and then it will fit on the data and try to find out the pattern inside the data. After finding, what we will do, we will simply create a one variable called y predict, and then we will call this linear model and then try to predict the test data, right? So it will try to predict the result of this test data, and then simply what we need to do, we need to compare this x test data with the y predicted data, right? So then we will find out what is the deviation between them, right? And for that, we need to use a matrix called R square score. You can use any matrix like mean square error, absolute error, but I am using the R square uh, as our comparator, right? As a matrix, and that matrix is inside the scalar matrix module, right? So for R2 score, what simply we need to do, we need to just call this, right, R2 score, and we need to pass this test value and the predicted value, so they can find out the relationship between the y test uh, and the predicted value, right? And it will give me some result, and that result will tell us that this R2 score is means this much amount of the variation inside the data, pattern inside the data is actually explained by the our algorithm. As you can see, this is a very bad result. This is expected because we have very less data and our dimension of data is very high. So in this case, this linear regression is nowhere close to give us any kind of good result. But I will show you linear regression because you can use this in some other scenario if you have a simple data. So my point is that for each and every algorithm, simply you need to call this their instance, fit it, predict it, and find out a score. Okay. Now try to use some other algorithms like decision tree. From the tree algorithms, we are going to use a decision tree to see how this data work on this algorithm, right? So simply we will call the tree module, and from tree module we simply has to call this decision tree regressor, the same process we are going to follow that we have follow in the linear regression part, right? So here you can see we have called this decision tree. Then again we need to make a object of this particular decision tree. Here we have named it DT model, right? And after naming it, again what we have to do, we need to do the fit part, and after fitting we have to do the prediction part, right? So we will do the fit, and in this one I just copy and paste this fit and paste here, right? And after that I think all is going to be the same. So I will type this y predict and then dt model, and from this dt model I will call this predict function and pass the x test value, right? I will pass this x test value. After passing, again we will copy and paste this values here, right? And if I run, you can see now it's giving us 72% of result, right? So I think it's a very good uh, prediction. It's giving us very good R2 score, right? As compared to the amount of data and high dimensionality in our data is there. So I am assuming that this is a overfitted model. It's nowhere close that it is going to give us this 72 2% of R2 explanation, right? It's okay. In later part, we will try to do some kind of hyperparameter tuning and see, right? So again, let's go and use the ensemble technique to perform this prediction. In the ensemble technique, we will use the random forest. That is the most common algorithm everybody will use. So random forest regression I will use. And again, the same process is there. I just name it something like RF model and make object. And after building the object, simply again I will do the fit part, right? And pass this x train and y train value. And after that, I need to know, we just need to copy and paste. I will do copy and paste and rename this DT model with RF model and try to run it. As you can see, it's giving me 56%. So my assumption is correct, like 72% is not a correct value, right? So it's giving a wrong value in the decision tree. It's overfitted one. So 56, I can assume that 56 is nothing, like 56% is explanation. It's not a good result. So let's try to use one more algorithm called XGBoost. So I think this will work good if you understand how XGBoost algorithm is working. So internally they are also selecting some important feature and doing uh, using the learning rate and other concept to tune the algorithm, right? So it's XGBoost is, then you can call XGBoost regressor as a framework rather than algorithm, right? So again, we are doing the same thing, just copy and paste and renaming all the instance. And after we run, as you can see, it's giving us a great result of like 69%, right? It's a great result is there. And if we go, we have done the linear regression, it's giving a very vague result. We have used the decision tree, it's giving 72%, which I am assuming is the overfitted one. Then we have used the random forest where we have given 56% of the R2 score. And then we have taken the XGBoost where it's giving us 69%, right? Now we will try to do cross validation and check that uh, how much overfitted our model is. Try to find out the for each and every sample of the data when we are doing the X train and test split, it will be taking a sample of data, right? So for different sample of data, how the result is coming, right? For that we will simply use a very nice class. It's called cross validation score, which is inside the model selection, right? And from this, what we will do, we will perform the cross validation on the data. For that, I will simply make one object, right? And for that, first I have to copy the one of the I can, okay, I will take the decision tree, right? This decision tree, I will take this code, paste here. So I'm only going to use the DT model, right? The instance one. for this. Here also we will see that what is the result is giving before, and during the cross validation what the result is giving, right? So I will just make one variable called score, all this cross validation, then we have to pass the model, dt model we have to pass, and after passing the dt model, right, and again we have to pass something like x and y value. So I am passing the instead of, I think, that's okay. Instead of x train, I should use x and y. So I am using whole data. I am not converting that into splitting that into x train and test. So I am using whole data, and then I am using the cross validation for 5-fold, and scoring type I am using the r square that we have used previously, right? And after that, what we will do? So after that, we will simply print the cross validation value. For that, I am just printing this score, right? And also I will print their mean value and a standard deviation. For that, I will simply go score dot mean, and then score dot standard deviation. So mean will give the average result for all the fold, and a standard deviation will give us the how much deviation is from the actual value, right? So as you can see, so previously it's giving 79%, right? And these are the value for 5-fold it's giving. So you can see for random forest, it's not giving us a very decision tree. I think we have used the decision tree regressor, right? It's not giving us good results. It's have a very much high variation, both from the positive and negative side, and it's giving us a mean value of 0.03. It's a 3%. It's a very bad in terms of algorithms, right? So we will try to use some other algorithms. Okay, let's use another algorithm, which is the random forest in this case, right? I will just copy and replace this code with a random forest, and then rename all the object, and again you can see it's giving way better result as compared to decision tree. So as previously you will see, right, I have said that 79% decision tree is overfitted. It's 0.03% previously giving, right? It's a bad. So for random forest, it's giving us a much better result. So now let's use the XGBoost. Okay, for XGBoost again we will simply copy paste, replace, and then run. So I am assuming it will give a more better result. So here you can see on average it's giving 65%. So it's a good explanation, right? And then a standard deviation of 0.64. So I think I'm assuming this is a much greater result as compared to previous one. So now what I will do, I will simply do the hyperparameter tuning for the XGBoost, right? So let's do the grid search CV. So for grid search CV, we simply use the model selection module from sklearn and import the grid search CV class. So basically we have two, grid search CV and random search CV. So in this scenario, we are going to use the grid search CV, right? So the same way you can use the random search CV only also, but some of the parameter might change, right? So first we need to create a parameter grid. So these parameter is going to use the combination of these parameter is going to use to do the tuning, hyperparameter tuning of our XGBoost class. So first I am taking the number of estimator, which is 100, 200, or let's say 300 I have taken, right? And after that I am taking uh, maximum depth, and for the maximum depth of that of the decision tree. I think the random forest decision tree I'm taking 3, 4, 5, right? And the learning rate also I'm taking. So as I mentioned, XGBoost is internally using the learning rate concept. So I'm using a learning rate like say the 0.01, then 0.1, I think, and then let's say 0.2. So these three combination, like number of estimator, maximum depth, and learning rate I will use, right? And this combination of parameter we are going to use to predict the hyperparameter of the XGBoost model. Then what I will do, I will simply making this grid search a variable, and the same way I call this grid search CV class, and in the constructor I am passing this estimator, which is the model, the XGBoost model, right? And then what I will pass the parameter. So param grid I will passing this param grid, and then I need to select the cross validation. So fold I will take again same as 5, and then we have to use the scoring. So scoring we are going to use the R square that we have used previously, right? And after that the process is simply the same. First fit it. So fitting I will pass x train, and then I will pass x. Okay, so in this scenario let's take x train, and then I will pass the y train, right? And after that what we will do, we will try to find out what are the best parameter for 5 folds, right? So from the given combination of parameter grids, it will give the best parameters. Now what I have to do, I will have to make a model like best model. So and again I need to create an instance, and for instance I will simply type xgb dot xgb regression and pass the best parameters, right? After passing the best parameters, uh, for grids CV will give us the combination, select the combination from the param grid, and it give us the best parameter, and from this best parameter we are passing this best parameter to the XGB means XGBoost regression, and this model, the best model, I will try to fit on the train and then on the test data. So first I will just fit that. After fitting the same thing, I will do the prediction for best model dot predict. I will pass the train, right? So I will pass the x test, and after passing the x test, I will use this r square. So r square value I simply use. In the r square, we pass the test and predicted value and print this r square. Let's print it r square. So it will take some time. I will skip and show you the result. So as you can see, it's giving 81% of the explanation for the best parameters, right? So it's quite good. And then what we will do, we will try to visualize the result. So you can see this code. I have skipped that one, the writing part. So it's a simple one. You simply have to plot, right? As you can see, we have a graph which line indicate the predicted value, and this dot indicate the actual value, right? And you can see there is clearly showing that our predicted value and the actual value are aligning uh, in the same place, and some of them are not aligning. That as you can see that we have it's giving us like 81% of R2 score, so some of them data points are going outside our prediction, right? Now we will try to save and load the data, right? For saving part, we simply use import pickle. From pickle, we will save and load. We will try to open a file in a write mode, right? So we'll name it like model.pickle, and we will write binary and make this this open object file object as f, and then we will dump that one, right? So dumping, we will simply dump this best model that we have trained, right? So with this best model with the best parameter, and then we will pass the file stream f, right? And if we run this code, it will save that in our uh, local solution. You can see it has saved, right? In the model.pickle it's had saved. Then again, what we need to do, we need to load the data. So loading the data, the process is very similar. Just name the model that we want to load, then open that in a read format, binary format. Again, make alias of file stream, then pickle that load. I think, yeah. So model I'm giving this name, and then load this stream. And if I run, this stream has loaded, right? And again, we will try to predict the results, so we can find out that this model is working or not. So we will pass this x-test data, and this x-test data will return some prediction. I will make y print as value. The same process we are doing that we have done previously, and then we will simply call this r2 score and pass this test and predict value. After that, we will simply run it, right? It's giving us 81% of the result. So previously also it's giving the same result, right? I think this is it for this video. In the next video, we will try to convert this entire notebook into solution, because in production we are not going to use the notebook in every time. If you are using Databricks or some kind of MLOps, you can use this notebook also directly. But for now, as we are going into the Dockerized manner, right? So we need to convert this notebooks into a solution, right? So from next video we will try to do start this conversion of this notebook to the solution part. So we'll simply make a Docker, right? If you have any question and suggestion, please ask in the comment section.